Okay. Good morning or afternoon, evening, depending on where you're dialing in from. This is called Intro to AI, and my name is Andrew Farah. I'm Density's CEO. I am, let's see, I am this person, um, and I work here in San Francisco, California. I live and work in San Francisco, California. So we build this thing, this device that is rather complicated, has about 800 subcomponents in it, and has taken probably 4 years off my life, if I'm really being honest, all to be able to count humans inside buildings. So density is sort of a system, can determine how many humans are in any given room, floor, area, or building in real time without invading privacy, essentially doing it anonymously. So we thought we would talk a little bit about today about how we do that, and as an explanation about artificial intelligence. We build this device, but we essentially can result in these fun applications like how busy are our cafeterias? Is there a line? Should I go now or should I wait? Can you notify me when the place is quiet? Or even let me know when the count is greater than a certain number of people. So these are some of the fun applications that we can build with data. So AI is not magic. And if you've done any reading, you've probably come across this concept. So this is probably not a new concept to you, but AI is not magic. It's mostly manual labor and math. So what we see and how we implement AI is on data like this. This is depth data. So we bounce infrared laser light. Lasers, fun fact, are really interesting, but kind of dangerous if you don't get range cal properly done, or power cal. Maybe a topic for another webinar, but generally speaking, ours are FDA, and we bounce these 4 infrared laser lights or infrared laser light off of objects as people walk beneath doorways, and we can count them. We generate depth data at 30 frames per second, and then we process all of this data locally on device. And we have to make sense of all of these strange behaviors and environments. You can see in the middle, people moving in different directions at the same time. On the right, a giant television of some sort. I think it might be it's a television. And then on the far left, you have someone who actually hides beneath the hinge of a door. These are all circumstances that are difficult for computers to understand, but very easy for humans to appreciate. It turns out the counting people is hard, largely because people are weird. They do very strange stuff in doorways. They linger, they carry plates. Sometimes they bring huge trash cans. This happens at 2 o'clock in the morning in very large buildings. And then sometimes they're dogs. We don't count dogs, but we do have to make sure that we're not counting them as people. So we take all that data and we turn it into what you can see here. So on the far right is a deep learned algorithm. It's making sense of people moving into and out of space in real time. All of this happens on the device, and on the left is the raw image. What's interesting about counting people is that counting people is actually not about just identifying humans. It's largely about identifying all the non-human objects correctly and then labeling them so that you can train a machine learning algorithm to understand how to delete them from the scene. So if it's not magic, how does this thing work? How do you get to this processed image? I came across this tweet and I thought it was really funny. So today I learned changing random stuff until your program works is, quote, hacky and, quote, bad coding practice. But if you do it fast enough, it's called machine learning and pays 4x your current salary. And all that means is that in order to train algorithms to be rather good or relatively accurate at identifying things that humans are naturally good at, you feed it a ton of data. But you essentially just keep telling the machine what is wrong or what is right until eventually it gets the right answer. What I'm about to show you, is what every large corporation that talks about artificial intelligence or machine learning is doing behind the scenes. They are manually painting. They're manually labeling or identifying or classifying what's happening inside of a scene. And this is done by actual humans. Oftentimes this is actually we have a system, we had to rebuild Microsoft Paint and the web so that we could start to train the system to better understand how humans, like essentially what was a human? What is a manipulated object? What is a door frame? And I mean, this has taken a very long time. But if you can sort of imagine that the today's version of outsourcing is a legion of mechanical Turks or a legion of individuals in other countries, essentially labeling data for American corporations, technology corporations. That's all in service of this. All we want to do is identify the two humans that come through this scene and ignore the thing that they're pulling in between them. But in order to do that, we have to go through a whole bunch of manual labor to arrive at the conclusion. This is another one, lingering, not identifying the plates. We only see the result in the flashy images and the nice blue boxes around people. But what is not talked about here is that the work that went into this was tens of thousands of hours, or many thousands of hours, into correctly labeling what a plate looked like. It turns out that plates actually look a lot like heads. They look like small children. And so we were massively overcounting in spaces where plates were being carried. We are no longer, but when we first started. The other side of this is something that's also not talked about quite as much either. You sort of just say, well, we'll just throw machine learning at the problem. The other side is quality assurance and reliability testing. So what you're about to see is our annotation system. So we actually have real humans for a statistical sample gut check our algorithm. So their job isn't to look at these, the images I've shown you, they all get destroyed on device in normal operation. But when we want to make sure that the device is performing properly, we'll do a period where we'll sample data, and then we will correctly label this data with actual human workers. And then we compare the human reported data with the algorithm reported data to get an accuracy score. Okay, so why do we go through all of this extra effort? Seems like a lot of work when we could otherwise, use something off the shelf. We don't want to become this. We think that it is reasonable for people to have an expectation of privacy in the future. And we think that you should be able to achieve all of the benefits of being able to understand how humans use the world without having to invade their privacy or their children's privacy. So this is actually an image from an article on COPPA, which is a COPPA. It's the Child Online Privacy Protection Act. If you have a second, I encourage you to go read a little bit about it. It's a really cool law that continually gets updated every few years as technology advances, as cameras advance, and as sort of artificial intelligence and machine learning advance. And there is a coming post Cambridge Analytica. There's a sort of a coming wave of privacy-oriented policy, regulation, and best practices. So we just think that you can get the benefits without having to be a camera. So we built this thing, and we built we spent quite a lot of time working on these things to achieve some very simple and straightforward goals. So we work with we call it like usage-based operations as opposed to time-based operations. So we have some hotels that use our system to monitor the number of guests in their lounges. When the count exceeds a threshold, they will add staff in real time. We have some airlines who use density in their lounges to add food and clean bathrooms based on busyness. Just like a fun fact, it turns out that we clean an enormous number of rooms that are already clean. We think that's kind of crazy. We should clean rooms based on whether or not they were used, as opposed to our estimation of when they might be busy, or when they might be dirty. So I'm about to show you a quick video. This is a security footage of one of our customers. We also help solve a problem called tailgating. And this is really interesting. Cameras tend to be rather bad at this particular function of counting people. And so a security professional applied us to this problem where an employee badges into a building, and then someone who doesn't work there, but looks like he does, catches the door right before it closes. This is called tailgating or drafting. And it turned out in this particular circumstance, something like $15,000 in new laptops had been stolen about 10 days later. And it took the security team, about 2 days, like 48 hours, to comb through all the video footage to figure out when this event even occurred. So today, this particular headquarters uses us to count the number of humans that enter the space in real time, so 0.7 of a second. and then compare that with their badge swipes. And if there's 2 entrances but 1 badge swipe, it sets off an alarm in less than a second. It's this really cool system that it's mostly people just holding the door for other employees. It's usually not nefarious, but it causes a whole bunch of unauthorized access issues. So this is an area that we help with, and it's specifically because we put so much effort into understanding how to accurately count people. And then, the other area is really just like identifying an enormous amount of space that's wasted. We have, in the US, there's 10.9 billion square feet of leased or owned corporate office space. 4.4 billion of that is vacant but paid for. And when I say vacant, I mean like not used, like no human entered that space, but still paid for each year. It's about $150 billion spent on space that is empty. And globally, it's north of 2 trillion, something like $2.1 trillion spent on space that is essentially vacant, which is crazy. Most organizations know that they have some of these problems. They just can't agree on which 41% is not being used. And so we help them identify the spaces that are in very high demand inside buildings and the spaces that are largely unused. And then, of course, we do all of these things, tailgating, usage-based operations, identifying space waste and improving space design. But you may just want to do something really simple, which is like figure out how busy your favorite coffee shop is. This particular cafe has a capacity of 480. So I have no idea who did this screenshot, but it's a massive coffee shop and clearly is about half full. But the general takeaway is this problem exists in a lot of different spaces, in sort of all relevant human spaces. And if we could just figure out how to deploy a system that doesn't invade privacy but provides very high degrees of accuracy, we can start to do some really fun applications. So yeah. So if you have any questions, I put my email up here. My email is just andrew@density.io, or you can reach out to contact@density.io. And I will start to do some questions. Thank you so much for attending our webinar. So give me just 1 sec, and I will pull some of these up. Why did you start Density? So this last slide, we wanted to know how busy our favorite coffee shop was. It wasn't called Main Street. It was actually called Cafe Kubal. And it's still around. It's in Syracuse, New York. It still gets really busy with very long lines in the afternoons. And so if you've ever lived in Syracuse, New York, being able to know how busy your favorite coffee shop is without having to wander through a bunch of snow is a very, very nice thing. Let's see. Types of companies that we typically work with. So we usually work with very large corporate customers. So we work with, call it some of the very large, I have to be mindful of who I can speak about. So we work with, call it within the top 25 tech companies, we work with maybe 30% of them. If you were to look at some of the large telecoms, we work with a lot of the large telecoms. We also work with a lot of universities, University of Notre Dame. We work with companies like Dropbox. We work with some government contractors and financial institutions, people who have very large corporate real estate, but are trying to understand how humans use that space, how their employees or their visitors use that space without invading their privacy. So we spent a lot of time trying to make sure that the product can go in places where there's a reasonable expectation of privacy. Let's see. There's a question about privacy and anonymity changing. I would actually say that I think that after Cambridge Analytica, we started to see quite a bit of pushback on organizations from individual users having an expectation that companies would protect their data. And in our case, we are not anonymizing the data. We really try to generate anonymous data from the beginning, which I would consider to be privacy by design, as opposed to privacy as an afterthought. And the reason that that's important is because if if a camera-based system or some type of system that does generate personally identifiable information ever gets compromised, the issue isn't just, hey, the system, well, it anonymizes the video feeds that it sees, or it anonymizes the still images that it takes. The real issue is, can you reverse that once compromised? And so we really don't want our infrastructure to ever be used against our customers. And so we try to be very mindful about privacy. Any thoughts about adding this to public transportation, buses and trains? Yes. So buses, it turns out, depending on where you live, buses sometimes are legally required to count the number of uses that they've had, meaning like the number of humans that have shown up to that bus. It turns out it's rather difficult to deploy a technology into a bus because the light conditions are constantly changing. And so you have to figure out how to, I would say today, the short answer is we don't deploy in buses. The long answer is I would love to deploy in buses. I consider them relevant human spaces. And I think that it would make a lot of sense to be able to know how busy each subway stop is in New York City. It would make a lot of sense to be able to know how busy each BART station in San Francisco is before you show up. And yeah, fun fact, also parking lots. Yeah, I'll get to parking lots in a sec. Fun fact, counting sheep, it turns out, is a very large business. Not for us yet, but cows and sheep apparently to humans are very hard to count. And they get fatigued while the farmhands sort of stand and count the animals coming back from pasture. So we've actually heard of we've had a number of requests to count farm animals, which we thought was really, really funny. Parking lots are interesting. I actually think there are better technologies than our system to count cars. And there's some really interesting stuff. Back when I think Clinton made GPS a certain level of a certain spectrum of I guess it's not spectrum, essentially a certain granularity of satellite imagery available to the public. That's sort of like the precursor to Google Maps. But what was really, really cool was when they allowed for that. Well, I don't know if it was cool. When they allowed for that, satellite started taking photographs of parking lots. And they did that in order to determine, they did it for hedge funds. They were counting cars in open area parking lots so that they could determine whether or not they should short Macy's. Seemed kind of a roundabout way to figure out whether or not you should buy or sell stock. But this concept of count is much more fundamental. It's a much more fundamental piece of data that tends to sort of pop its head up in lots of different proxies. So a proxy for count, like in subways, you have trains that run on a certain time-based schedule. That time-based schedule is a proxy for the demand for that transportation, which is a proxy for knowing how many humans there are going to be. And that's the reason that certain trains run at longer intervals later on in the evening, just because there isn't as much demand. So I guess what I'm saying is that there are a lot of things that are essentially proxies for how many humans need a thing. And once you can figure out how many humans are inside of a system, you can start to do some really fun load balancing. Have you ever noticed anyone trying to skew their data by somehow altering how busy their space looks? Is that even possible? That is the first time I've ever heard that question. And that's interesting. No, we have not run into that. I'm thinking through how that might be useful. Unless, of course, you're Macy's and you're trying to create fake holographic cars so that people will buy your stock. I haven't really encountered a circumstance in which the incentives to skew your data were worth the effort to do so. But yeah, that's probably going to become a problem in the future. So I think there will be some interesting spaces where perhaps control over how much you can modify the data or skew the data in terms of admin privileges will probably need to be limited. We've run into some interesting circumstances around first responders wanting to know how many humans are inside of a building if they ever show up during an emergency. I think that's really interesting. It requires very high degrees of accuracy, but that's sort of a circumstance in which you don't want people like deleting the digital version of count, ahead of something like that. That's an interesting question. Thanks for asking it. Who has access to the analytics platform? I.e., if I wanted to see how busy my favorite coffee shop was, do I need to download an app? So most of our customers are large corporates, like I mentioned, who are using this system for their internal buildings, and we deploy and sell that product and platform so that their employees can see how busy their coffee shop, their cafes are, or how busy their cafeterias are, or if rooms are available. We began with our coffee shop. That was like where this whole problem started. I would like to end there as well. I just think that we're going to have this interlude in corporate real estate because it's a really great distribution mechanism into other space types. So if you have a coffee shop that you love and you would like them to deploy density, don't hesitate to let them know that they can reach out to density. That said, the reality is our primary focus is large corporate customers. That is sort of where we spend all of our time. And so there isn't an application. You could go download the Density mobile application, but you wouldn't have access to any places that I think would be interesting to you. I'm working to change that. I'm working to spend the next 10 years, however, to change that for you, anonymous question asker. Other questions? Other questions? Oop, there's no one. Does an API exist for downloading your own data and conducting? Yes. Does an API exist for downloading your own data and conducting your own analytics? Yes. So if you go to docs.density.io, you'll actually see our API. And it was the first thing that we built. And it was a thing that we actually believe probably has the most long-standing power inside of systems. Is like, people count as super relevant in the context of whatever data you're interested in. And we wanted to make it easy for you to be able to, in real time, query how busy a space is from many miles away, from a continent away, or from right next door. And to do that inside of whatever system you care about. So the short answer is yes, there is. And yes, you can with your own analytics system. Other questions? We're at about 10:24. I'm happy to answer anything else. Pretty much open book when it comes to density related stuff. I also really enjoy talking about this. And what's interesting is like, there's no feedback from all of you except for the questions, which I really appreciate. There's no like verbal feedback. So it's mostly me just talking to myself near my dog over here. And I appreciate you all bearing with me. Okay, if there's nothing else, I know that this will be recorded. So you should be able to share this if it's at all interesting or useful. And if you have any questions that you didn't ask today, but that you're curious about, please don't hesitate to reach out to contact@density.io or to me directly, which is just Andrew@density.io. Thank you so much for the time. Really appreciate you spending a Tuesday morning or afternoon or evening, wherever you are, hanging out with us, and hope to see you at the next webinar.